Today in this session we study about the periodic properties of elements in a periodic table such as atomic size, metallic character, non-metallic character, electron affinity, ionization energy and electronegativity. If we consider an atom, say atom has a nucleus and here we have a K shell, L shell and M shell. Atomic size or the atomic radius means it is a distance from the center of the nucleus to the outer shell. The distance from the center of the nucleus to the outer shell we call the atomic radius, and it has got a unit. That unit is called an angstrom. When we consider a molecule in the sense it is a combination of atoms. See, it is called the internuclear distance. The half of the internuclear distance also can be called the atomic radius. That means while considering a group or a molecule, atomic radius means it is a half of the intermolecular or internuclear distance. We consider how the tendency of atomic size down a group and across a group. First we see the tendency of atomic size, whether it is decreasing or increasing down a group. Consider these elements. Group 1 elements. In group 1 we have hydrogen with atomic number 1. That means in the K shell 1 electron there, and thereafter lithium 2 1 and sodium 2 8 1, then thereafter potassium 2 8 8 1. So you see, when you go from top to bottom of a group, the number of shells increasing. Here only one shell. When you come to the lithium, there are 2 shells. When you come to the sodium, there are 3 shells. Then potassium, 4 shells are there. So top to bottom, what happens? The number of shells increases. So what happens when number of shells increasing? Number of shells increasing, that means the number of protons increasing. That means here the atomic number 1, that means 1 proton. Here the lithium, there are 3 protons, atomic number 3. Here atomic number 11, that means 11 protons. Here atomic number 19, that means 19 protons. Since the number of protons increasing, the nuclear charge increases. What nuclear charge is? Nuclear charge is a charge of a nucleus. In the nucleus we have protons and neutrons. 2 people are there in the nucleus. So the charge of a nucleus is called the nuclear charge. So top to bottom, what you see, the nuclear charge increasing. So the nuclear charge has always an attraction over the outer shell. Nuclear charge pulls, or the nucleus pulls the outer shell towards the nucleus. Okay, so here you see, since one shell there, more attraction over the outer shell there. When you come to the downwards, down the groups, here 2 shells there, the nuclear charge is supposed to travel to the 2 shells. Here nuclear charge is supposed to go till the 3rd shell, and the nuclear charge is supposed to go till the 4th shell. Since the number of shells increase, that means since the distance from the nucleus increase, seeing the force of attraction of the nucleus or the nuclear pulling getting decreased over the outer shell. Always nuclear pulling is very effective on the outer shell, as the inner shells are completed. You see, the shell is completed. Inner shells are completed, so that what happens? The nuclear pulling is always effective on the outer shell. So down a group, what we observe, the nuclear charge increases. Even though the nuclear charge increasing, what happens? The nuclear pulling down a group decreased. Okay, nuclear pulling down a group decreased, or the outer shell getting decreased. So what we see, top to bottom, the number of shells increasing, so that the atomic size also getting increased. What we observe while going from top to bottom of a group, the number of shells are increased, so that the nuclear pulling getting decreased, even though the nuclear charge increased. So top to bottom, the atomic size is increased. Okay, once again, top to bottom, the atomic size is increased due to 2 reasons: the decreasing effect on nuclear pulling and increased number of shells. Number of shells are getting increased. While considering the atomic size from left to right of a period, we see we have a period 2 from lithium to fluorine. You see here, all these cases we have 2 shells. 2 1, electronic confidence 2 2, 2 3, 2 4, 2 5, 2 6, and 2 7. Okay, so all these cases 2 shells are there. But you see the atomic number increases. Here atomic number 3, 4, 5 to atomic number 9. Atomic number 9 means there are 9 protons. So nuclear from 3, proton number 3 to proton number 9, a corresponding increase there. That means the nuclear charge increases from left to right. Nuclear charge increases means nuclear pulling also increases. But the number of shells remains same. Number of shells remain same, but nuclear pulling increasing. That means the nuclear pulling or the outer shell is getting increased from left to right. Okay, left to right, the nuclear pulling or the outer shell is getting increased since there is no addition of shells. Here, nuclear pulling increasing, the same way number of shells remain same. So nuclear pulling will be at highest when we come to the right side of the period. So left to right, atomic size will be decreased. The outer shell will be pulled towards the nucleus, so that what happened? The atomic size left to right of a period getting decreased. Okay, again I repeat what? Atomic size from left to right is decreased due to 2 reasons: increasing increasing effect of nuclear pulling, as well as no addition of shells, number of shells remaining same. Second character is metallic character, metallic nature of elements. Okay, see what is metallic character? Metallic character is a character of losing of electron, losing nature. Okay, losing of electron we say metallic character. Then while considering the metallic character, we say metallic character depends on 2 factors. First one is atomic size, atomic size, and the second one is nuclear charge. Atomic size and nuclear charge. See, if we consider top to bottom of a group, how the atomic size is. Atomic size increased. Atomic size increased due to the addition of shells and lesser nuclear pulling. And how the nuclear charge, top to bottom, the nuclear charge increases, but nuclear pulling is getting decreased top to bottom as number of shells increase. Okay, we see metallic character down a group. Since down a group, atomic size increased. So the net effect of nuclear pulling is weaker over the outer shell. So an atom easily loses electron from the outer shell. Okay, while considering from left to right of a period, okay, in the period what happens? The nuclear charge increases, nuclear pulling also increases, and number of shells remains same. So an atomic size is smaller, getting smaller towards the right side of the period. So the atom cannot easily lose the electrons. We say from left to right, metallic character, the losing character decreases. So left to right, metallic character decreases. And top to bottom of a group, since atom loses electrons faster, we say metallic character increases from top to bottom. So hope it clear? Top to bottom, metallic character increases as atomic size increases and weaker nuclear pulling. And left to right, since atomic size is getting smaller, atom cannot lose electrons. So metallic character is getting weaker from left to right. While considering period 2, the lithium and beryllium, we say they are metals, and boron, metalloid. And if we again go to the right side of the period, we say the non-metallic character increasing. That means the metallic character left to right decreases. That means non-metallic character, of course, increases. While considering the metallic character of a group 1 elements, which we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Since francium is a radioactive element whose properties are yet to be studied, we would say cesium whose metallic character is higher than that of other elements in the same group. While considering the non-metallic character, it is also dependent on 2 factors, the atomic size and the nuclear charge. We have already seen in case of metallic nature, top to bottom what happened, the number of shells increased. So that what the nuclear pulling of the outer shell is getting weaker. Okay, so we see the same way, since top to bottom number of shells increase, nuclear charge is weak, atom easily loses. Okay, so that metallic character increasing, but The same way, non-metallic character, we would say non-metallic character decrease. Top to bottom of a group, non-metallic character decrease. And while considering the left to right, what happened? Atomic size is getting smaller. Atomic size is getting smaller from left to right of a period. So since atomic size is smaller, due to that, high nuclear pulling is there. Or we say left to right proton number, nuclear charge is getting increased. Since more nuclear charge is there, more nuclear pulling is there. Since number of shells are remaining same, so what we say, atomic size is decreased. So atom rather gains electron than losing. Okay, rather it gains electron. Gaining nature we would say non-metallic nature. So left to right we say non-metallic nature increases. Non-metallic nature increases from left to right of a period due to two main reasons, as nuclear charge increases, so that nuclear pulling also increases, as number of shells remains same. Group 15 elements. We know top to bottom what happens? Atomic size decrease, so that metallic character increase. The other way, non-metallic nature top to bottom decreased. We consider nitrogen and phosphorus. They are non-metals. Again, going down the group, arsenic and antimony, they are the metalloids. And if you go again bottom, we see bismuth and moscovium. They are the metals. So top to bottom, metallic character increase as number of shells are getting increased. Nuclear charge, even the nuclear charge increase, the nuclear pulling of the outer shell is getting decreased. So atom easily loses electrons. So metallic nature top to bottom increases. So if we simply say the bottom of every group, we would say they are metals. Let's see the fourth property, chemical reactivity. It simply depends on the nature of an atom or the capacity of an atom. How does it lose electron or how does it gain electron? Okay. Losing or gaining nature of an atom decides how does it react with the other elements. Here too we consider down a group and across a period. While considering group 1 elements, we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So as I already told you, francium is a radioactive element whose properties are to be studied. So while going top to bottom, atom easily loses electron as number of shells are increased, nuclear pulling is weaker. So top to bottom, atom easily loses electron. So since atom loses electron faster top to bottom, we would say cesium is a best metal among the group 1 element. As I told you, francium is a radioactive element whose properties are yet to be studied. While considering the reactivity across a period, we see group period 3 from sodium to chlorine. So as I already told you, what happened when we go left to right of a period. Left to right of a period, the atomic size decreased as nuclear pulling is increased. More nuclear pulling on the right side of the period, so the atomic size is smaller. Okay, so sodium loses electron. The one electron in the outer shell, sodium loses. Magnesium also loses, but sodium loses faster than magnesium. So sodium, it's a more reactive than magnesium. Magnesium and aluminum, we consider magnesium and aluminum. Magnesium loses electron 2 electron, aluminum also loses 3 electrons. But magnesium loses 2 electron faster than aluminum. So we would say magnesium is more reactive than aluminum, while sodium is most reactive than aluminum or magnesium. Well, come to the 17th group. Sulfur gains 2 electrons, so chlorine also gains 1 electron. Okay, so but chlorine gains faster than sulfur gains. So who gains faster? Chlorine gains faster. So we would say chlorine is more reactive than phosphorus or sulfur. So left to right, the capacity of gaining increase. So it gains faster. We would say it is more reactive. Sodium, it loses faster, so we would say sodium is more reactive. So I already told you, reactivity depends on how fast an atom loses electron or how fast an atom gains electron. This ionization energy, that is the energy required to convert a metallic atom to ion. From the title itself, the meaning there, the energy required to convert a metal to ion. Energy, metal, ion. Okay, so you see a sodium atom here, 281. So we know sodium, since it has one electron outer shell, it loses electron. But simply if you call an electron will come here, if somebody says the electron doesn't come, then we know the electron, it simply cannot go out. So how do we make this electron out? So for making the electron out, we are supposed to spend some energy over the outer shell. Why does it come out? Because the outer shell is getting pulled towards the nucleus by the nuclear charge. So we call it the nuclear pulling. So the electron, it doesn't simply come out. It will not come out. Okay. So what we do? We supply energy there, energy to the atom. Or simply we say we forcefully take this electron outside by applying a energy, external energy. We forcefully take this electron outside. So the energy we supply, the energy required to convert atom the positive ion. And these all things taking place, this energy we can supply especially when the atom is in the gaseous form. By applying an energy, we converted a metal to metallic ion. The metallic ion we call a cation, positive ion. When a metal is converted to ion, we say cation. So what we say, the energy required to convert a metal to its cation, we call the ionization energy. We see the ionization energy down a group and across a period. Down a group we know the atomic size is increased, so that the nuclear pulling of the outer shell is getting decreased, so that an atom can easily lose electron. So ionization energy, the energy required to convert an atom to become positive ion. So the energy required to remove one electron. That is, when we move from top to bottom of a group, lesser ionization energy is required to remove an electron from its outer shell. That is, top to bottom, ionization energy decreased. So what happened when we move left to right of a period? Left to right of a period, what happened? Atomic size is increased, so that nuclear pulling is very high. Since more nuclear pulling is there, the atom doesn't release electron easily. So more ionization energy, more energy is required to remove an electron from its outer shell. That means from left to right, ionization energy is increased.